Welcome. This screencast is part of our very last lesson in Math 140 at SUNY Geneseo. It talks about irrational numbers, which elementary students really don't ever run across. Irrational numbers are numbers like the square root of 2 and pi, where you have decimal approximations that never stop and never repeat. Small children don't usually talk about irrational numbers. Well, what makes them irrational? They are irrational because they don't terminate, meaning they never stop, and they don't repeat. That's what makes them irrational. You never know what number is coming next. You never know what digit is coming next in the sequence of numbers. They are irrational. They don't stop and they don't repeat. Well, why don't they repeat? Well, we sort of know that pi is 3.1415926.5 and so on. It does bother me in Night at the Museum 2 when the Einstein bobblehead doll says 3.1415926.5 to be exact. It's not exact. There are decimal places after that, zillions of them, but it's a bobblehead, so we will forgive him. Why couldn't this possibly repeat? Well, let's pretend that this was the part that did repeat, that it would start back up again, 1415926.5. If that were the case, then we could take this number and do the thing that we did in a previous lesson. We could turn it into a fraction. And irrational numbers cannot be expressed as a over b, where a and b are whole numbers. You cannot make a fraction integer over integer, whole number over whole number, doesn't really matter. You cannot make one out of this. This is irrational. Irrational numbers don't stop, don't repeat. And so they cannot be expressed as fractions a over b, where a and b are integers. This is a huge thing to think about. Because, so if we look at all of the numbers that we have ever studied, these are the real numbers. We started with the natural numbers, 1, 2, 3, 4, 5, and so on. And then we added 0 and got the wholes, right? And then we added -2 and -5. You know, you got 2 and 5 in there, but we added -2 and -5 and we got the integers. And then we went a step up from that and we got the rationals, the quotients. 1/3, 2/5, 5 over -2. We got the rational numbers. But numbers like pi and the square root of 2 exist outside of this realm. They are real numbers, but they cannot be expressed as fractions at all. They cannot be expressed as fractions of integers at all. Pi is out here, the square root of 2 is out here. This is where the irrational numbers live. They are real, but they are not fractions in any way, shape, or form. And it turns out, you'll love this, there are infinitely many more of these than there are of these. And yes, there are infinitely many fractions, but there are many, many more numbers that can never be expressed as fractions. And that's crazy to think about. And so we won't think about it for too very long. But that's crazy to think about. The irrational numbers, the square root of 5, the number 1.123456789101112, and forever. That number is irrational because it never repeats. Uh, there are infinitely many more numbers like that than there are numbers like we have been studying all semester long. Crazy thing to think about. We'll talk in another screencast about how to approximate the square root of 2, how to approximate the square root of 3, things like that. But that's it for this screencast, and I hope that it is instructive.